KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hello students, now we are discussing maxima and minima. Last class we discussed basics of maxima and minima. Okay, now we will discuss some more concepts and examples and the concept of maxima and minima. Okay, now example 26, find the maximum and minimum value if any of the function given by f of x equal to x square, x belongs to R. Here what is the question? Find maximum and minimum values if any, means if exist. Okay, if maximum exists, what is the maximum value? If minimum exists, what is the minimum value? Okay, of the function f of x equal to x square. Here x is any real number. Okay, x you can consider between minus infinity to plus infinity. Okay, but y is equal to x square is a upward parabola. Y is equal to x square graph. This is y is equal to x square graph. No, y is equal to x square graph, upward parabola. Okay, now y is equal to x square, upward parabola. Now from the graph itself you can say that function has only minimum value. Minimum of this function is what? 0. Minimum of this function is 0. Okay, at what point? When x is equal to 0, when x equal to 0, f of x equal to what? 0 square is 0. Okay, in remaining cases, if x is other than 0, in remaining cases f of x is positive because the square of a real number is always positive. So what we can conclude, f of x is greater than or equal to 0 for every real number. F of x is greater than or equal to 0 for every real number. F of x is greater than or equal to 0 for every real number. Okay, now this function f of x equal to x square or y is equal to x square graph. Now what you can observe, now f of x equal to 0 when x is equal to 0. Okay, f of x equal to 0 when x is equal to 0. Okay, in remaining cases f of x is positive. So what we can conclude, f of x equal to x square, this function has minimum value. What is the minimum value of this function? Minimum value of this function is 0. Minimum value of this function is 0. At what point? At x is equal to 0. Okay, minimum value of the function y is equal to x square or f of x equal to x square is 0 at x is equal to 0. Two things here you have to remember. What is the minimum value of this function? Minimum value of this function f of x equal to x square is what? 0. At what point you are getting a minimum value? At x is equal to 0. Okay, minimum value of this function is 0. And point of minimum is at what point you are getting minimum value? Point of minima is what? 0. At x equal to 0 you get minimum value. Okay, that is what it is written here. The minimum value of f of x equal to x square is 0 and the point of minimum is x equal to 0. Minimum value of this function is 0. At what point? At x is equal to 0. So x equal to 0 is point of minimum. Point of minimum. Okay, minimum value is 0 and point of minima is 0. Okay, now as x approaches to infinity or x approaches to minus infinity, f of x equal to x approaches to f of x equal to x square approaches to plus infinity. So as x value increases, f of x value increases. Okay, as x value, suppose if you consider x value 100, Now f of 100 is what? 100 square, x 1000 square, x million square, x is minus 100 whole square is 100 square. Okay. Now either x value increases or x value decreases, f of x value increases. Okay. Now we cannot find maximum. We cannot find maximum for this function. So only minimum exists for this function. Minimum exists, and minimum value of f of x equal to x square is 0 at x is equal to 0. So minimum value of this function is what? F of x equal to x square, minimum value is 0 and point of minima is 0. Point of minima is x equal to 0. What about maximum? Maximum does not exist. As x approaches to infinity or x approaches to minus infinity, f of x approaches to infinity. Okay, like this. Okay, so f has no maximum value and hence no point of maximum. And hence no point of maximum. Okay, now f of x equal to x square, only minimum exists. Minimum value is 0 and point of minima is x equal to 0. Okay, f of x equal to x square does not have maximum value and hence no point of maximum. Now if you restrict, because here x you consider as a real number. Suppose if you restrict a domain to some something like closed interval minus 2 to 1. Okay, if you restrict the domain from minus 2 to 1, closed interval minus 2 to 1. Now minima is 0 only. Okay, minimum value is 0 at x equal to 0. Okay, now between minus 2 to 1 means graph will be restricted between minus 2 to 1. This part only will restrict, no? So here f of minus 2 is how much? F of minus 2 is minus 2 square, nothing but 4. Okay, f of 0 is 0, f of 1 is what? 1. So in this case f will have a maximum value. F will have maximum value. What is the maximum value? Maximum value is minus 2 square, nothing but 4. At what point? At x is equal to minus 2. At x equal to minus 2. Okay. If we restrict the domain to some closed interval, it will have minimum value as well as maximum value. Okay. If you write only for real numbers, all real numbers, f of x equal to x square will have only minimum value. Minimum value is 0 and point of minima is 0. Okay. Now if we consider something like x belongs to other than all real numbers, if I restrict something like this, minus 4 to 2, closed interval minus 4 comma 2. Okay. Now in such case f of minus 4 is what? 16. F of minus 4 is minus 4 square, nothing but 16. So f of x equal to x square has a maximum at x is equal to minus 4. Okay, so maximum value in that case is 16 and point of maxima is x is equal to minus 4. So if you restrict domain, we can write minimum and maximum. If you are giving x belongs to all real numbers, only minimum value exists. Minimum value exists at x is equal to 0 and minimum value is 0. Okay, minimum value is 0 and point of minima is 0. Okay. Next question, example 27. Find maximum and minimum values of f if any of the function f of x is equal to mod x, where x is any real number. X is any real number. This is similar to previous question. Now if you observe mod x graph something like this. Okay, y is equal to mod x, this is nothing but y is equal to x line, this is y is equal to minus x line. Okay, now y is equal to x square and y is equal to mod x, both are symmetrical about y axis, both are even functions, both are symmetrical about y axis. Okay, now if you observe here, as x approaches to infinity, y or f of x is also approaches to infinity. As x approaches to minus infinity, f of x approaches to plus infinity. Okay, as x value increases or x value decreases, f of x value increases. Now if you observe, f of x is equal to mod x, this graph has a minimum of mod x is what? 0. That is when x is equal to 0. Other than x equal to 0, f of x equal to mod x is always positive. F of x equal to mod x is always positive. So f of x is greater than or equal to 0 for every real number. Okay, from the graph we can observe that, because graph is in first quadrant and second quadrant. No? In first quadrant and second quadrant, in first quadrant both x and y positive. In second quadrant x negative, y positive. So y is positive, f of x. F of x is nothing but y. So y positive. So f of x is greater than or equal to 0 for every real number. Okay, f of x equal to mod x is greater than or equal to 0 for every real number. Okay. Now also f of x equal to mod x is 0 when x equal to 0. So f of x equal to mod x has minimum value. What is the minimum value? 0. At what point? At x is equal to 0. So f of x equal to mod x has minimum value 0, and the point of minima is what? 0. Means at x equal to 0 you have minimum value. At x equal to 0, f of x equal to mod x has minimum value, and the minimum value is 0. Now here what is the minimum value and point of minima? What is maximum value? What is point of maximum? Okay. Now f of x equal to mod x has minimum value at x equal to 0, and the minimum value is 0. F of x equal to 0. Okay. So function f of x equal to mod x has minimum value 0, and the point of minima is x equal to 0. Okay. Now if you observe graph, as x approaches to infinity, y approaches to infinity. As x approaches to minus infinity, y approaches to plus infinity. Okay. Also from the graph it is clearly shown that f has no maximum value in R, and hence no point of maxima, and hence no point of maximum. No maximum value does not exist, hence there is no point of maximum. Okay. Now if you restrict the domain, instead of all real numbers, if you restrict to something like minus 2 comma 3, minus 3 comma 2, okay, closed interval minus 3 comma 2. Okay. Now point of minima is x equal to 0 only. No? At x equal to 0 you get minimum value. Now minus 3 to 2, if you restrict, so graph minus 3 to 2, up to here only will get. Okay. Now f of minus 3. F of minus 3 is what? F of minus 3 is modulus of minus 3. Modulus of minus 3 is 3. Okay. So when you restrict to some closed interval minus 3 to 2, okay, then f will have a maximum value. What is maximum value here? Modulus of minus 3 is 3, and at what point? At x equal to minus 3. Okay. When you restrict the domain to some interval minus 3 to 2, for example, okay, minus 3 to 2, now f has maximum value how much? 3. So maximum value in this interval is what? 3. Maximum value in this interval is 3, and point of maxima is what? Point of maxima is x equal to minus 3. Means at x equal to minus 3 you have maximum value. X equal to minus 3 has maximum value. At x equal to minus 3 maximum value exists. Okay. So point of maxima is x equal to minus 3. Okay. And maximum value is what? 3. Okay. And also one more thing you have to observe. Now y is equal to mod x. But this is a function is having minimum value at x equal to 0, but if you observe, this function y is equal to mod x is not a differentiable function at x equal to 0. Y is equal to mod x is not a differentiable function at x equal to 0. But at x equal to 0 it is having sharp edge, okay, sharp corners. If you have, function is not differentiable at those points. Okay. So y is equal to mod x, this function is not differentiable at x equal to 0, but still there is point of minima. Okay. Function may or may not be differentiable at a point, still a function may have minimum or maximum. Okay. Okay. Next example, no? Example 28. Example 28. Find maximum and minimum values if any of the function given by f of x equal to x, where x belongs to open interval 0 to 1, where x belongs to open interval 0 to 1. Okay. Now what we have to find? Find maximum and minimum values, if any, means if exist, maximum value exists, what is the maximum value and what point you have maximum value. Okay. If minimum exists, okay, what is the minimum value and what is the point of minimum. Okay. Now f of x equal to x, now x belongs to what? Open interval 0 to 1. So in between 0 to 1, 0 excluded as well as 1 excluded. Open interval means endpoints are not included. Closed interval means endpoints are included. Okay, as x belongs to open interval 0 to 1. Okay, now f of 0 is what? 0. F of 1 by 2 is what? 1 by 2. F of 1 by 3 is what? 1 by 3. F of 1 by 4 is 1 by 4. F of 3 by 4 is 3 by 4. F of 5 by 6 is 5 by 6. F of 99 by 100 is 99 by 100. F of 1 is 1. But at 0 and 1 function is not defined. Okay, so holo circle at x equal to 0, holo circle at x is equal to 1. Now this is the graph y is equal to x between 0 to 1. This is the graph y is equal to x or f of x equal to x between 0 to 1. Holo circle at x equal to 0, holo circle at x is equal to 1, because 0 and 1 both are not included. Both are not included. Because 0 and 1 both are not included, because x belongs to open interval 0 to 1. As x belongs to open interval 0 to 1, x belongs to open interval 0 to 1 means 0 and 1 both are excluded. Okay, in between numbers only it is defined. Now if you observe this graph, as you move from left to right, 0 to 1, graph is going upward. So it is a increasing function. F of x equal to x is increasing function, strictly increasing function. Strictly increasing function. Now if you observe from the graph, it seems that f of x equal to x has a minimum value near x equal to 0, means close to 0, f of x has a minimum value. Okay. Now if something like this, if I write x has f of x equal to x has minimum value at x is equal to 0.0000, or else 0 point, after decimal point I will write 1000 times 0, after that I will write 1. So that is close to 0 only, no? So what is that function value? 0, 1000 zeros and 1. Is it very close to 0? It is close to 0, but still you can write numbers close to 0 than this. What number I assume? X equal to 0 point, after decimal point 1000 zeros and 1. Now if I assume x equal to 0 point, after decimal point 2000 zeros, after that I will write 1. So this number is close to 0 compared to earlier number. This is close to 0? Yes, this is close to 0, but we can write one more number, not one more number, we can write many numbers close to 0 than these numbers. So close to 0, we cannot, it is not possible to locate points closest to a particular point. We cannot, it is not possible to locate points closest to a particular number. Okay, also maximum wise also, if you observe from the graph, you can observe that closest maximum value occurs a point closest to 1. Okay, point near to 1, very close to 1, you have a maximum value. But close to 1 or closest to 1, how we can locate? That is not possible. That is not possible. That is not possible to locate a point very close to 0, very close to 1. These are not possible. Okay, now for example, if I consider x naught be a point closest to 0. Okay, if x naught is closest to 0, x naught is a number closest to 0. Now x naught by 2, if you divide number by 2, it is obviously less than that number only, no? Now x naught by 2 is even less than x naught. Now this point is close to 0, no? Now if you consider this point is close to 0, now divide this number by 2, that point is close to 0. So it is not possible to locate a point closest to a particular number. Okay, now if you consider 0.5 10,000 zeros, after that I'll write 1. Okay, if I consider that as x0. Okay, and one other number x1 or x2. Okay, x2, I'll write 0.1 light year times 0, after that I'll write 1. Now this point is close to 0, no? So it is not possible to locate a point closest to 0. Similarly, it is not possible to locate a point closest to 1 also. It is we can observe that minimum value is very close to 0 and maximum value is very close to 1, but how much close? That points not possible to locate. That points not possible to locate. Okay, that is what it is written here. The given function f of x equal to x is an strictly increasing function in the given interval 0 to 1. From the graph of the function f, it seems that it should have minimum value at a point close to 0 and maximum value at a point closest to 1 on its left, means just below 1 you have to write, just above 0 you have to write. Okay, right side of 0 and left side of 1 you have to write, because you cannot go beyond 1, you cannot go less than 0, because here x belongs to closed open interval 0 to 1. Okay, so it is not possible to locate points closest to 0 or 1. So if you consider x0 is close to 0, x0 by 2 is even close to 0. Okay, now if you consider x1 is closest to 1, now x1 plus 1 by 2, this point is greater than x1, means this point is more closer to 1 than this point. Okay, so it is not possible to locate points closest to 0 or 1. So this function has neither minimum value nor maximum value in the interval 0 to 1. Okay, now if you assume suppose instead of open interval 0 to 1, suppose interval is given f of x equal to x belongs to closed interval 0 to 1. Okay, x belongs to closed interval 0 to 1. Now in such case, minimum of this function is 0 at x equal to 0. Okay, maximum of this function is 1 at x is equal to 1. Okay, if you consider interval as x belongs to closed interval 0 to 1, in such case minimum exists and minimum exists at x is equal to 0. Okay, and maximum exists, maximum value is 1 and at x is equal to 1. Okay, in that case both minimum and maximum exist, but here in this case in open interval neither minimum nor maximum. Okay, minimum does not exist as well as maximum does not exist. Okay, now you can assume that every monotonic function, monotonic function means either increasing function or decreasing function, we call them as monotonic functions. Okay, for monotonic functions minimum and maximum exist at endpoints of the interval or endpoints of the domain of the function. Okay, next, and one more thing, here f of x equal to x, if you consider x belongs to closed interval 0 to 1, both minimum and maximum exist. Okay, so what we can write is every continuous function on a closed interval has a maximum and a minimum value. Okay, every continuous function on a closed interval has a maximum and minimum value. Now this is a continuous function, this is a continuous function, this is a continuous function, all the three functions are continuous functions only, you know. If you write a closed interval like minus 2 to 1 or minus 5 to 10, something like this, if you write closed interval for a continuous function, every continuous function on a closed interval has a maximum and a minimum value. Okay, I will continue remaining concepts and problems in next class. Thank you.